Hello, and welcome to our webinar on IoT Energy Management with KaaIoT's automation flow. I'm Andrew, software engineer at KaaIoT, and I'll be your host for today's session. KaaIoT's mission is to make IoT device management, tracking, and analytics easy for both large-scale business applications and homegrown IoT projects. Our platform provides powerful tools and services to optimize energy management, streamline operations, and enhance efficiency in various industries. Today, we are going to dive into IoT energy management based on the KaaIoT's automation flow feature. We would like to show you the power of automation in action with real-life examples. On the slide, you can see what we have in store for you. We will start by exploring the concept of automation in real life. Following that, we will introduce you to our newly released rule execution service. We will also use real-world examples to show how the automation flow feature of the KaaIoT platform can make it easier to automate office lighting and climate control for better energy management. After that, we will hold Q&A session where I will answer your questions. So feel free to ask questions simply by using the comment section on YouTube. Before we begin, I would like to say a huge thank you to everyone who has joined us today. I'm hoping you will find the webinar informative. All right, let's kick off this exciting journey and discover how KaaIoT's automation flow can streamline your IoT and energy management. Get ready for informative and engaging session. Let's go. In our daily practices, we frequently encounter automation tasks where certain devices need to operate automatically without human intervention. Let's consider a few examples. Plant watering system. This system utilizes readings from soil moisture, ambient temperature, and other sensors to determine if the watering pumps need to be activated. Energy saving system. This system utilizes presence and temperature sensors to decide whether to turn on the space heating system or the air conditioning system to regulate the temperature. It also ensures that heating, air conditioning, and lighting are turned off when staff leaves the office. And finally, leak protecting system. This system utilizes leak detectors to determine if water supply taps need to be shut off and sends a notification to the technician about the issue. These are just a few examples, but they all share a common requirement. They need for a tool that can monitor device parameters, make decisions based on logical operations, and execute specific actions accordingly. Until now, third-party systems like Node-RED were used to fulfill these requirements. However, that is no longer the case. We're excited to introduce our new rule execution service. The rule execution service is currently in active development and offers the following features: tracking changes in endpoint metadata, setting rules that can be logical expressions containing observable endpoints metadata, and creating different types of actions linked to specific rules and executed when the logical expression within the rule evaluates to true. There are 4 basic actions. Command execution action. It sends a command to an endpoint which you specify during the creation of the action. The command body can include both static and dynamic parts. The dynamic part can contain endpoint metadata key values that will be substituted during the action execution. Metadata update action. It changes the value of a metadata key for an endpoint which you specified during the creation of the action. The value, like in the previous action, can also be dynamic, meaning it depends on the metadata value of the particular endpoints. Next goes webhook action. It triggers a post request to the URL specified during the action creation. The body of this request can be dynamic, like in previous actions. Finally, the rule execution action. It creates action chains by combining multiple actions. It means that we can make some rule be executed as a result of another rule's successful execution. Currently, a rule is triggered when there is a change in a metadata key value used in the logical expression. We have plans to expand the capabilities of rules in the future. We have features that are coming soon. In addition to the current features, we have many exciting capabilities that will soon be introduced. More supported actions, triggers tied to time intervals as in cron, using time series as triggers, and many others. Let's get down to business with our first built-in automation example. To demonstrate the capabilities of our new service, let us start with a simple case with office lighting automation. Let me introduce you to the Hamster Incorporated, a tech startup that is yet to go big. In the meanwhile, they occupy a tiny office and wish to save on electricity bills. The problem is sometimes employees forget to turn off the lights and air conditioner when leaving. Using this button here, we can simulate whether someone is present at the office. As you can see, there is nobody at the office now, but the lights and the air conditioner stay on. Let's now have the hamster founders back to the office, setting up the automation. First thing first, they will need smart lights and the presence sensor. To speed things up for this webinar, we have already set up the device endpoints in Kaa. Let me quickly show you the presence sensor. This is a Kaa generic endpoint device page. What I would like to show you here is the presence detected metadata attribute, which indicates the current state of the sensor. You can see that it's set to true, meaning that there is someone currently at the office. I want you to remember this attribute because we will use it as we set up automation rules. We will also use the endpoint ID for this device to set up automation specifically for it. Let's now go back. Apart from the presence sensor, we have also configured the light switch actuator. So everything is ready for the setup of the automation rules. Let's go to the rules section. Let us add a rule to track the value of the presence detected metadata key in the presence sensor endpoint. Let's call this rule is office occupied. The description is optional, but let's put detect if somebody is at the office. As the expression, we will use the prepared expression. Let's break down this expression piece by piece. Endpoint metadata. It indicates the trigger source. This ID is the ID of the presence sensor endpoint in Kaa. Presence detected. It specifies the metadata key value we are interested in. These symbols, they frame our expression, turning it into a template for processing the service internal logic. The result of the expression will be either true or false. Now let's check if our rule is working correctly. After entering an expression, we simply click on the Test Rule button. Here we need to enter test metadata keys used in our expression and their values for the test. Let us test our expression. Let's click on Evaluate and see if the rule worked successfully and what it returned. As you can see, the result is true, which is what we expected. The testing process allows us to ensure that our automation is functioning as intended, and all the necessary conditions are met for our actions to take place. Remember, for the actions related to a rule to work, the rule must return the true value. Let's now save the rule. With the presence detection rule in place, we now need to ensure that the lights turn on when someone is detected. For this purpose, let's create an action. We assume that the light relay is already connected to the KaaIoT platform and can handle commands from it. So the most appropriate way of action would be command invocation. Let's create the action with the following details. For the name, we will write light on action. Description is optional, but let's write something like switch on the office light. As for the endpoint, we have to specify the endpoint of lighting. Command type is a type of command to be sent to the relay. It's going to be a light on off. Command payload expression. The command body here can be dynamic or static. To simplify, let's use a static command body. Let it be state on. Let's save the action. After creating the action, we need to bind to the rule that will initiate it. So let's bind light on action to the isOffice-occupied rule. For that, we need to go to the Rules tab. For isOffice-occupied, we would like to manage actions. And here we would like to add light on action. Note that we need to specify the actions type as command invocation. Alright, now the rule will trigger the action. Let us now quickly set up a similar rule, an action pair to toggle the light off when there is nobody present at the office. For that rule we will add the name isOfficeVacant. For description, let it be detects the office is empty. Expression, I'll just use the expression that I have prepared for you, just to save time. Let's create. This rule will trigger when there is nobody at the office. Now to the action. We need to make sure that our action type is command invocation and add another action. Let's name it light of action. Description is switch off the office lights. As for endpoint, we will use lights. Command type is the same as the previous one. And for the payload expression, we will write state of. Finally, let's bind light of action to the isOffice vacant rule. For that, we again go to the Rules tab, manage actions for isOffice vacant rule. Here we need to make sure that the command disvocation is the action type, and we need to add the light off action. Let's click Save. We have successfully created an automation using the new car rule execution service. Please note that the automation algorithm has been intentionally simplified for demonstration purposes. In reality, it would consider various timeouts and nuances related to personal behavior and presence sensor operation. Now let's test how our automation works. Let's go back to the main dashboard. For that, we go to the Solutions, find Webinar, and our hamster incorporated dashboard. Let's simulate everyone leaving the office with our presence simulator button. Now we can see that the room state has changed and everyone except for the hamster left. In the lighting logs, we can see the recent light switch command. We can also see that the status for the lighting widget has changed. Now if we toggle presence back on, everything powers up again. Everything works as planned, so we have set up our simple office light automation system. Let us now tackle a slightly more complicated problem with air conditioner control automation. Hamster Incorporated wants to maintain a comfortable temperature range of about 21 degrees Celsius, 70 Fahrenheit. So when it gets hot, they want the air conditioner on, and they want it off when it gets cool. But besides that, there is no point in having the air conditioning running when there is no one at the office. So this time around, we want two sensors, the presence sensor and the temperature sensor. Jointly control the air conditioner actuator. Before we proceed to setting up the rules, let me quickly show you how we will simulate the temperature change at the office. We have wired up this button to change the simulated temperature sensor state. As you can see, it currently shows 24 degrees by Celsius. If we go to the temperature sensor endpoint dashboard, you will see that this is the temperature that is currently reporting. If we go back here and click the simulation button, you see the temperature changing to 18 degrees by Celsius, which is also what the sensor should report now. I also want you to note here that the air conditioning keeps running despite it's already pretty cool here. This is because we have not set up any automation yet, so off we go. Okay, let's add a new rule. First, we will create a rule called is air conditioning needed. The rule will determine whether it's necessary to turn on the air conditioner in the office. So in the description field, let's put checks if the air conditioning is needed. The trigger for turning on the air conditioning is when the temperature in the office is 22 or higher degrees. So the expression for this rule will be like this. We have seen a similar expression before, but note how this time around we combine the data from two different sensors and decide whether the air conditioner should be running. The first endpoint ID is the ID of the presence sensor, and we want someone to be at the office for the air conditioning to run. As for the second ID, it is the ID for the temperature sensor, and we will toggle air conditioner on only when the temperature exceeds 22 degrees by Celsius. Alright, let's save the rule. If the result of this rule is true, we need to change the state of the air conditioning system, turning on or off. To achieve this, we must connect the corresponding action to the rule, which will change the state of the air conditioning system. Let's use command invocation action type to control air conditioning, like we did with the lighting in the previous example. For that, we need to switch to the Actions tab. Let's create a new action called air conditioning on action. The action will switch on the air conditioning in the office. The details of the action are as follows. So for the description, we will add switch on air conditioning in the office. As for the endpoint, we will use the endpoint of the air conditioner actuator. It's going to be like this. As for the command type, we'll write change state. As for the payload expression, we will put state on. Next, we attach air conditioning on action to is air conditioning needed. For that, we again go to the Rules tab. We use manage actions for the is air conditioning needed. Let's make sure that we have the command invocation for the action type. And then we add air conditioning on action and click save. Done. Now the rule will trigger the action. With the next step, let's create a rule and action to turn off the air conditioner. Following a similar approach, we will create a rule called Is air conditioning not needed? And an action called Air conditioning off action with the corresponding details. Let's create a rule. Let's put checks if air conditioning is not needed. As for the expression, I'll use such kind of expression. And let's create. Let's create an action. Let's make sure that we have the command invocation. Let's add a name, air conditioning off action. As for description, let's add switch off air conditioning in the office. As for the endpoint ID, we again will use the air conditioner actuator. Change state for command type and the state off for payload expression. Let's create. Finally, let's bind action to the rule. For that, we need to manage actions for is air conditioning not needed. Here we need to make sure that the action type is command invocation again. And let's add air conditioning off action. Let's click save. And this is it. We have now successfully implemented an automation system to control the office temperature using the car rule execution service. Let's go and see how it works. As you can see, there is someone at the office and it's warm. So the air conditioner is running. Let's toggle the temperature simulation to 80 degrees by Celsius. As soon as we click on this button, a command is sent to the AC actuator and it switches off. You can also see the command triggered by automation in the logs view here below. Now, if we switch the simulation temperature back to 24 degrees by Celsius, the air conditioner switches on again. But all of this only works while someone is at the office. Let's toggle the presence off. You see that the air conditioning is now off and it will remain off until someone arrives, no matter what the temperature is. And this completes the demonstration of the basic automation rule engine capabilities for today. Living Hamster incorporated fully automated and happily conserving energy for the planet and money for their big idea. With KaaIoT's automation flow and the rule execution service, you have the power to transform your IoT energy management and create sophisticated automation algorithms tailored to your specific needs. Whether it's controlling lighting systems based on occupancy, managing energy consumptions in office spaces, or implementing complex temperature control systems, automation is at your fingerprints. Remember, the possibilities are endless when it comes to IoT automation. So start exploring, experimenting, and leveraging the power of KaaIoT's automation flow to optimize your energy management and enhance efficiency in your IoT ecosystem. Before we proceed to the Q&A session, I want to express my sincere gratitude to all the participants who joined us today. I hope you found this webinar informative and valuable. I also want to extend our thanks to our development team, which worked tirelessly to bring these automation capabilities to life. Your feedback is crucial to us. We would greatly appreciate it if you could take a moment to share your thoughts and suggestions. Let us know how useful you found the webinar and how we can further enhance it or the KaaIoT platform as a whole. Once again, thank you for joining us today. Stay tuned for more updates and advancements as we continue to work on improving our IoT platform. And let's now proceed to the Q&A session. So, our first question. Okay. Our first question is from Anna. How is secure user authorization implemented in Kaa, and where does Kaa store the user data? Oh, actually, we are using the Kaa identity and access management, which provides comprehensive unified user resource access and permission management. It implements best practices in case of storage, and additionally, the disks where the data stored are also can be encrypted. Next question goes from Carl. Do you have the ready dashboard to control temperature and air conditioning in multiple buildings, like supermarket chains? Maybe you can offer it custom built. Currently no, but we are considering the possibility to create a template that would cover these features. Next question is Michelle. Can Kaa analyze temperature data, build graphs, and send summaries via email? For example, weekly, daily. I am for the teachers board and we want to track classroom conditions to improve the learning process. We use Power Analytics engine that can cover these needs. However, it's currently not possible to send emails recurrently. But we are planning to implement this in the near future. The next question from Kate. What is the cost for running Kaa on our premises? Will we be able to customize alerts and functionality? And there is one more sentence. We have old air conditioners, so can Kaa team help with connecting them to some kind of smart controllers? Okay, Kate. Cost of running Kaa on your premises consists of two parts. First part is the license price. The pricing for Kaa self-hosted is based on the number of active endpoints and on some technical details such as white labeling, etc. We would be happy to send you our standard packages over an email. Second is the infrastructure price. Based on your load, it can vary from $100 per month based on your cloud provider or hosting price. As for customizing alerts and functionality, yes, you will be able to do that. And of course, we provide professional services and can certainly help you with connecting your devices. Okay. Next question from Johnny. Is it possible to program Kaa to automatically switch power of the watering system from solar to the general grid and vice versa for more economical usage? Yes, you can totally do that. You can program by yourself or connect with our team to do that. I guess it will be our last question for today. If you have any other questions, please feel free to email us directly to support.kaiot.io. All in all, thank you guys for being with us today. See you on the next Kaa webinars. Stay tuned.